Okay, so we're going to talk about the radian right now and what the radian is. So if you look at the slide that's before you, we can read the definition of the radian. The radian is a central angle of a circle whose vertex is on the center of the circle. An intercepted arc of a circle is the portion of the circle with endpoints on the sides of the central angle. Okay? If you look at this one right here, here's your circle, right? Here's your central angle. Now, central angle is a definition, right, a vocabulary word from Monday. Okay, so it is a vocabulary word that might be on your vocabulary quiz tomorrow. So central angle here, right, so that the vertex right here is the center of the circle, okay? And the intercepted arc, do you see that, is the arc that's created by the central angle, okay? Make sure you're focusing on what's going on in front of you instead of worrying about something that's going to happen in the future. All right, so let's talk about radius and radian. A radian is a measure of the arc that is equal to the radius. Okay, here's the radius, and here's a radian. Okay, so if you have a circle, right? If you have a circle that has a radius of 5, what's the radian equal to? Right, the radian is going to be equal to 5. Okay, if you have a circle that's equal to, has a radius equal to 7, what's the radian going to be? 7, right? So does the radian change? With every circle, right? Because it's always equal to the radius. So when the radius of the circle changes, then the value of the radian changes, right? Okay, so the radian is a relationship, right, to the radius. So if you look at this next part, it says a radian is the measure of the central angle that intercepts an arc with a length equal to the radius of a circle. Okay? Now, when we're going through, we're going all the way around the circle, the full circle measures 2 pi radians. Always 2 pi radians. Okay? Therefore, 2 pi equals 360 degrees, right? Or pi equals 180 degrees. Yes? Okay. Oops. It's not letting me grab the shade. Sorry. Okay. Now, here's the part that you're most interested in. How do I convert from degrees to radians, and how do I convert from radians to degrees? Okay. If you have degrees and you're going to radians, you're going to multiply by the ratio pi over 180. If you have radians and you want to get degrees, you're going to multiply by 180 over pi. Okay, now let's think about that. How many of you have chemistry right now? When you have chemistry, what is the thing that you learn? Factor label, dimensional analysis, what do you call it? Okay. So in that particular concept, whatever unit you're trying to get rid of goes where? On the bottom, okay? Use the same concept. You have degrees and you're trying to move to radians. So what's going to go on the bottom? Degrees. You have radians and you're trying to get to degrees. So what goes on the bottom? Radians, which is pi, right? So you're always going to use pi and 180. The question is going to be whether it's pi over 180 or if it's 180 over pi. Yes? Let's do a couple of examples and see if we got it. Okay? The first one is pi over 2 radians. So if I have pi over 2 radians, which one will I use? Radians to degrees. Very good. Radians to degrees. So if I'm trying to use radians to degrees, okay, how will I set that up? Well, I'm going to say A is pi over 2, right? I'm going to multiply by what? I'm trying to get 2 degrees. So 180 goes on top over pi. That's going to give me 180 pi over what? 2 pi. What happens to pi? Pi is going to cancel. And I'm going to get what? 90 degrees. See how we did that? 180 over pi? Or how did I get? Oh, I multiplied 180 times pi. Just multiplying straight across. Why would I? It's not. Yeah, that's not how we do that. Yeah, we're gonna do them. I just was trying. I was gonna move it to another page so I get more room. Okay. So now let's look at B. Okay. B is we have 225 degrees. Now, I recommend that you go ahead and put that over 1 for your placeholder because some of us really still struggle with multiplying fractions. So we need that placeholder to keep us straight. I have degrees and I'm looking for radians. So which one will I use? 180 over pi or pi over 180? Pi over 180. So I'll say pi over 180. Okay. That's going to give me 225 times pi over 180. Okay. Now, I can get a decimal. When I do this, I would say 225 divided by 180, and it becomes 1.25. So it can say 1.25 pi. Okay. Now, here's the deal. Those of you that are going into pre-AP Algebra 2 next year, you're making the jump. This is not going to be accepted. Okay. What would we rather? No, we leave it in terms of pi, but instead of 1.25, what is a better way to represent that value? Almost. 5 pi over 4. So if you're going into pre-AP, this is going to be the preferred answer. Okay, this is not going to work for you. For most of us, for right now, this is going to be okay. Okay, so let's go ahead and look at 2 radians because this is done just a little bit differently. In this particular one, they've already multiplied by pi, right? See how this one is pi over 2 radians? That means that it's in terms of pi. When you have 2 radians, it means they've already multiplied by the 3.14, okay? So you still use the same fraction. I'm going to put this over 1 for a placeholder, right? I have radians. I want degrees, so which one do I use? 180 over pi. Okay, so I'm going to get what? 360 over pi. Guys, you just multiply across the top and multiply across the bottom. Now, in order to get this in radians, or excuse me, in degrees, I need to go ahead and divide by 3.14. Okay, so I would say 360 divided by 3.14. Okay, and what will I get for that one? Yeah. What do you think, guys? Could you do that? Yeah? Okay. Isaiah. You'll get the closest answer by using 3.14 because that's what most of the text will use, but you should be with rounding close enough not to matter. Okay? Since it's only one calculation, you're not going to carry a rounding error into multiple calculations. You should be okay. All right, so let's go ahead and do these right here, okay, just to practice. I do want to point out this one because there's one on your paper that's negative in degrees. You can do it the negative with a negative 90, but for our purposes, we don't really have to deal with negative radians yet. So I would go ahead and change negative 90 to positive 270. Does everybody see how I got that? Positive 270 from negative 90? If you're going around the circle, right? If I'm at my starting point, if I go backwards 90, right? That's negative 90. Where would I be if I had gone forward at 270, right? So you can change your negatives to positives, right? All right, I'll give you about 10 minutes just to practice these. Feel free to jump around. Make sure you do some of each one, and we can check them and move on if you don't have any questions.